Well, hello, everybody, and welcome back to this week's Google Hangout with the OpenShift Origin community. Today we are lucky to have a Red Hat alumni, John Hawley, who's now with Intel as the Open Hardware Tech Evangelist inside of the Open Source Technology Center at Intel. I've heard a lot of words to say he gets to play with the robots these days, and heard a lot of minnows. Google of summer coders are under his are his minions these days, so he's got a lucky job. And also with us today, we have David Strauss of Pantheon. He is the CTO and co-founder of Pantheon, which is one of my favorite Drupal and WordPress now hosting providers, and a huge Fedora systemd contributor. So we're really, really pleased to have him here for this conversation about persistence. It's my persistent conversation about how to get persistent files supported in an ephemeral world of the cloud. And you know, OpenShift is a platform as a service. It serves up its applications in wonderful containers that we call gears, and those gears are ephemeral. Software applications like the CMSs that are WordPress and Drupal have a requirement still to solve that problem and to store their files and their images and their content in a persistently available file directory. And that's always been slightly problematic for OpenShift. We've got lots of little workarounds, and we'll be having a conversation today about a new project that John started when he was with Red Hat, and now has brought with him and continued working on, called SyncDiff. It grew out of some work around rsync, but I'm going to let John jump in and give us a little background on SyncDiff, and then we'll have a conversation about whether or not that solves our problem, if it's a stepping stone, and ask David for some of his thoughts on that. And I think we're going to be joined by a couple of other folks from Black Mesh, Jason Ford and Dan Reed. They can navigate the wilds of Google Hangouts. So I'll let John do some talking and then go hunt for the Black Mesh for us.
Okay, thank you, Diane. So, yeah, SyncDiff started while I was at Red Hat. I was the OpenShift storage architect at the time. So all of my problems involved actually this exact thing. How do we deal with, creating persistency in an ephemeral, system? And the way storage inside of OpenShift works now is it's all local storage to the main node. So all of the storage that all of your gears are running on is all effectively local. So, whether that's your local hard drives, your EBS volumes that are attached, the ephemeral disk inside of Amazon EC2, those kinds of things. So it's, and that works for the most part pretty well for 50–60% of the applications. It's when you start trying to, do scaling that this starts breaking down. And that's because, what happens when my second gear is on a different node? Now I can't, now sharing that disk space, sharing any of that data becomes more complicated. And there are some, obvious ways that, this can get solved. Things like Ceph or Gluster or GFS2, these clustered file systems. Now, these are, really interesting technologies. They're coming up, but Gluster and Ceph, at least when I was doing my testing and my verification of them, they had some issues with how they would work within OpenShift. There were some performance issues. There was some, issues with OpenShift and trying to use these. There's, one of the, if nothing else, one of the bigger challenges was that OpenShift doesn't use unique user IDs or group IDs for things within the entire cluster. They are, UIDs and GIDs are actually only unique within a realm. I'm going to forget the exact terminology there, but it's basically a group of nodes. So what happens when my gear now spans multiple realms? There's an issue. So, yes, these are the correct technologies that OpenShift wants to use, but between those technologies not being there yet and OpenShift having a few issues that it needs to solve, this wasn't going to happen anytime soon. So SyncDiff came out of this need to have some sort of a synchronization mechanism to get the data across these multiple gears in multiple locations, and not have to worry about some of these issues like the UIDs, the GIDs that may or may not come up. And so I looked at rsync, I looked at csync 2, I looked at Unison. There's a bunch of different things out there, but something that everybody's got to remember is that storage is fundamentally hard. Everybody wants to think that it's really, really easy, but if you do anything in storage, you'll understand very quickly that it is one of the most complicated and insane things that happens on a computer. Because you as a user, you as a programmer, you as anything other than that storage device, storage is absolutely critical. If the data that you put down on disk does not come back out in the exact same way, how is it any better than dev random and dev null? So, and so these synchronization systems, rsync, csync 2, Unison, they're all trying to come at the synchronization problem from slightly different perspectives, both because of when they came about or when, what they were actually trying to accomplish. So things like rsync. Rsync is actually mostly a replacement for SCP or even, copy on a local system. So it was trying to make those transfers a little more efficient, and what it really brought to the table was the ability to, particularly across the network, make those transfers efficient. But it didn't really come with any of the work built into it to do multi-way synchronization or two-way synchronization and those kinds of things. Now, with a shell script or a Perl script and a hammer, you can kind of make it work, but it's not ideal. So, eventually this brought about, things like Unison and csync 2, which are kind of doing, again, similar things. Unison, extended the idea that, these file transfer, these file synchronization ideas so that you could do two-way, but it really kind of fails beyond two. You can, again, with a hammer and enough force, you might be able to get it to work, but again, it's not going to be robust. It's not going to be what you want. Csync 2 kind of extended the idea to being able to do multi-way. So, we're finally at least in the right realm for what something like OpenShift needs, but it has the problem of needing an absolutely persistent server process on each node that's going to run this. And trying to keep things persistent inside of OpenShift is not only a not recommended, you probably really don't want to do that, because that kind of defeats the purpose of an ephemeral system that's coming up, coming down, doing things. So, after staring at all of these, trying them, seeing if I can get them to work, I eventually pitched, this idea that Peter Anvin and I have been talking about for about a decade, because we were looking for something like SyncDiff at kernel.org when I was there. And I ran kernel.org for about a decade. We never really had the time or energy to start this. But it's basically a stateful version of rsync, and that is, more or less what SyncDiff is. We kind of steal some ideas from Git, we kind of steal some ideas from, rsync and whatnot, and we kind of mash these all together. And what happens is SyncDiff keeps its own copy of all of the metadata of all of the files that you're trying to synchronize. So, why do we do this? Because we want to know what actually happens and changes on disk. We want to be able to have a line in the sand inside of our own program of, okay, at one point, file foo had, timestamp, X, Y, and Z. The next time we go to look at foo, the timestamp had changed. So that we, at that point, we can actually detect that something's changed. We should update our own metadata and be able to alert, other systems that things have changed. So when we were talking about this for kernel.org, it was really about trying to eliminate rsync's need to walk the file system every single time a client came in to sync the data. And the way rsync works is, you spin up the process, and it has no metadata about anything that's on disk. So it has to literally walk the entire file system from end to end, build up the tree, and then once it's got all of that, that's when it can actually start transferring files. They've done a little bit of optimization, but you still have to incur this entire file system walk. And if you're on a really busy server system like kernel.org, this file system walk is incredibly expensive, particularly when you start talking 20, 30, 40, 100, 1,000 clients. And disk just has a problem, spinning disk particularly just has a problem keeping up with that. So, now that, so we've got some of the requirements, and, we've got a little idea of what SyncDiff is doing. It's, it's pre-caching this metadata, and when a client comes in and asks for, okay, like it asks, the last time I talked to the server, you had transaction ID, looks like a get SHA-1 sum, because that's actually what it is. And the server says, okay, great, these are the files that have changed since that SHA-1 sum. Boom. So instead, and the intention with SyncDiff is all of these transaction IDs, all of these change IDs, are getting generated either through iNotify or some other server process, or even the administrator just manually running their own file system walk across the data, so that the admin, the server runner knows exactly when that file system walk is going to happen, so they can limit when that's going to happen to try and control this stampeding herd problem. This comes with an obvious downside, because if SyncDiff metadata is out of sync with the actual file system, that doesn't get reflected to any of the remote machines. This is why we're looking at we're adding iNotify support, and it's being extended to other operating systems. I think FreeBSD is the next one that's going to get added, because we've got a Google Summer of Code student who's actually working on that. He's made some fantastic progress about getting that iNotify support into SyncDiff and getting the notifications back out to the remote machines of these changes, so that they can start and initiate their own sync. So, and I guess I should at least mention that SyncDiff, with the exception of the notifies, is an entirely pull-based system. There's no pushing from any single point. And this has a specific advantage, because then the coordination is simpler. I can set up a machine, I can declare it effectively the master, but then any number of clients, assuming that they have the right credentials, can log in and pull all that data and ask that server for all of that information. Instead of a central authority having to go in and manually add every single machine. So we're still picking up a lot of the ideas from Git and rsync and these things that came before it. So, and so at this point we've got code. It's up and running. It syncs files. It's got a couple of warts, because basically we're at the point of it's alpha level code. We have the framework to build all of the pieces that we need to build on top of it. We've got like I said, we've got a Google Summer of Code student working on the iNotify code, and I've seen that working, and so that's awesome. We've got another student who's working on soft delete support. So if you've ever been in the mirroring world, at some point, your primary master server will accidentally delete a bunch of stuff it's not supposed to delete. And of course, as soon as that happens, that delete cascades across the entire mirror system, and then you have to retransfer all of these files. So with SyncDiff, we're actually going to change that a little bit. Instead of outright deleting those files up front, we're going to make the assumption that there's some flap in the system. And we're just going to do a move operation, stick them into a non-synchronized location, and we're going to let them sit there for some defined timeout period by the admin of that local system. Now, that timeout could be 0, which means they would just get deleted. But if there is a timeout, they'll sit around, and should those files suddenly re-exist, maybe in a different location or whatnot, we'll recognize that based on the SHA, the checksum of the file, and then instead of having to transfer that file, we just move it back into place.
Yeah.
So
that sounds like a very handy feature.
Yeah, no, and if you've ever watched how Fedora sometimes syncs, it's like every other release, there's this big old flap, and something happens, and half the tree gets deleted. So, this is one of those things of, okay, yes, half the tree may have been deleted and it may not be visible, but at least putting it back's really, really cheap. So, and it gives you, as a side benefit, not that this is intended, but it also gives you a backup in case you've accidentally deleted something. You guys
do have a project site. It's Sync.
It's
Share that, and just so people can find it if they want to find the code and contribute.
SyncDiff.org. There we go.
There we go.
I apologize for the appalling logo, but yeah, we've got a website, and I am anything but a web person. But as you can see, we've got a website. It's at sync, SYNC, diff, diff.org. And it's a pretty basic website. There's a little bit of documentation here. We've also got a mailing list, which if you go to syncdiff.org/mailman, you'll find the main mailing list. And there's not a whole lot of activity in here. Mostly our Google Summer of Code students interacting with us. But one of our students has done a phenomenal job of doing some documentation. His name is Lovepreet Singh. He's over in India, and he's written, in trying for him to understand how things work, he's written some fantastic documentation, including, these nice state diagrams of how, like the soft delete should work, and how the protocol all basically works, and some things like that. So it's, I mean, I'm very glad he did this, because he's actually got a better understanding of how everything works because he did this, and the code he's writing now is actually better than what I would have expected him to be doing. And unfortunately, neither of the two Google Summer of Code students were available today to meet with us. One of them is traveling, and the other one's in the Ukraine, so completely different time zones. And just, yeah.
So in terms of integrating this into OpenShift, would this be a cartridge, like a cron cartridge, or something that we would add in once it's working, or how do you see it being integrated and being made available inside of OpenShift?
Okay, so right now, with what we've got, you could integrate it. It would require, the server process right now still has to stay up, so you'd have to keep at least the gear alive so that the server process can run. But the file scanning, you can just put that into a cron job, run that every 5 or 10 minutes or something. Yes, your data may not be absolutely up to date, but depending on what your application is and what your intention is, even being, up to, having those files synchronized every minute may be good enough. Once we've got things like the iNotify support completely in, you shouldn't need to do the cron jobs anymore. So that would go away. There's also, at least literally on a piece of paper that I've written, there is a method to deal with putting a CGI script in front of the main server process to have the CGI actually run inside of the web server, so that when you want to do a synchronization, you actually use HTTPS as your transport mechanism. It'll automatically spin the backend process up for you, at which point then the server process doesn't even need to stay resident, assuming that the gear isn't so that the gear does not have to prevent the idling. But unfortunately, I mean, while I've got these all mapped out and I've got these on paper, they're not done yet. And and SyncDiff is now effectively my hobby project. I've got some time within what I'm doing here at Intel to work on it, but it's definitely not my focus anymore.
So what I'm trying to do a little bit with this recording is recruit a few of the other people who this is near and dear to work on it with you and to do something. And I've got a couple of I don't want to call them suckers, but a couple of contributors lined up to give some of their spare cycles on this as well. So that's why I'm really glad that it's happening, and hopefully we can get them signed in and working on it with you and testing it out, because I definitely would love to see this tested out on OpenShift and see if we can't bring it to one of the Drupal cons sometime in the not too distant future. But so while we have David here, David's got years and years, because you're ancient, aren't you, of experience working and delivering persistence for Drupal sites over at Pantheon. And I'm wondering, David, if you can tell us a little bit about how you do it at Pantheon and what you're thinking about this approach that we're proposing. I know it's not optimal, but I'm wondering what your thinking is, and where do you think we can do better or do more?
So the let's see. So the primary design challenges we try and solve for our Drupal infrastructure at Pantheon is that probably the hardest is read after write with the persistence layer between all the servers, where we may have upwards of anywhere from 10 to 50 application server containers that have to have access to the persistent files for a given website to spread out the load for the to be able to deliver the kind of bandwidth and traffic or concurrency and traffic that these sites need to be able to have. And you need the ability on Drupal to be able to write a file and then read it, not even necessarily the next request from that user, but possibly another request on the same page with some sort of Ajax-like component. For example, it's very common on Drupal content management to have a node edit form up to upload an image, and then what the node edit form will do is it'll try to load a thumbnail for the image. And the way it creates the thumbnail is using, it's called different things in Drupal 7, but image cache, which is the idea that there's a path that defines the kind of attributes of the derivative image in terms of its dimensions, its crop, other possible filters that might be on it. And then by requesting a certain URL, it tells the system what image is the original and what image, what properties need to be applied to the derivative. And then if that already exists in the file system, it'll just deliver it at that path. And if it doesn't, Drupal traps the 404 and then pumps out the file using PHP, and then at the same time writes it to the file system, so subsequent requests for that derivative image are able to get the direct thing off disk. But
and here I thought that was just magic inside of it.
Oh, it's far from that. So there are a few different approaches to it. We've taken the approach of taking a pretty hard line on read after write with our different boxes, where if it's uploaded to one thing, then it needs to be able to be readable at that path from the other nodes in the system, and we need to be able to handle the events where maybe it hasn't completely propagated out yet. So the alternative approaches being things like you can do things like try and make sessions sticky, and that works to some degree. It doesn't work for situations like publishing a node where if you have a node that has an image on it, the preview thumbnail you see in your edit form may be different than the actual version of the image that gets viewed on the view form. And so when you actually save a change to a node, someone else from a different computer may try and load that node, or it may be rendered other places on the site and use different derivatives. So it's really hard to get away from the problem of read after write consistency in the system. So what we do is we actually have a genuine distributed file system. And by genuine, I mean it uses the file system layer as a driver in Linux boxes using Fuse rather than trying to populate the files on disk. And what we do here is we have a kind of server client system that we call Valhalla. And for each container that mounts the file system, it uses its certificate to authenticate to the file system cluster that maintains the volume for that particular kind of set of application servers. It might be the development environment for example.com. It might be the live environment for that site. But it's kind of a volume where if the file gets written on any of those servers, it should be readable on the other ones. And then what happens is that when a file gets written in the system, when it mounts the volume and writes a file, it uses that kind of HTTPS connection with the client certificate to maintain a nice kind of encrypted and authenticated access to that volume. When it writes the file, it logs it into an event stream for the volume on the server side. And then all the other clients that are mounting that file system, when they try and access a given file, if that file is not locally available or if there's been some sort of window of time in terms of when it refreshes the cache, it pulls down the event stream, and then it'll basically patch the local cache of metadata and file, and it won't download new file content just because it's been changed, but it may invalidate local file content if it has been changed and doesn't need to be accessed. And then that way, we're able to work with situations where they may have hundreds of thousands of files in a file system, possibly millions. A single directory may have hundreds of thousands of files. One file may get written to that directory. We can't just invalidate the directory and then have it load the whole new content. Now that's not as much of a problem if you're syncing out to the file system like SyncDiff does, because then when you're iterating through those files, listing them, working with them, you're really directly working with the local file system and kind of watching it. But in our case, we had to create an efficient mechanism for that. The other advantage of a true distributed file system, the way we're doing it versus the kind of SyncDiff approach, is that some of the file footprints for our users can be upwards of terabytes. Yeah. And when we want to spin up a new container, we don't want to copy down terabytes of data. We may not even have terabytes of disk on the system that that container is spinning up on. And what our system allows us to do is have the file content lazy loaded, where when a file needs to get accessed on a container, Fuse is able to know that that's happening. It's able to pull down the right file content, and then it's able to provide it out. And the only visibility the application has into that happening is a slower request than if it had the content cached locally. And then that allows us to minimize the amount of state that has to be maintained in each of these containers. And then the way that we maintain the metadata and file system content is kind of like a content-addressed version of PNFS, in the sense of PNFS distributes the responsibilities for file content storage and file metadata storage so that you can have a relatively few number of metadata servers or a metadata server and then distribute the file content over many boxes. In our case, we have our metadata stored in Cassandra, and then we use S3, and then we content address the file content using SHA-512. So if the same file actually exists across multiple volumes, say for a workflow for a site, we only keep one copy of that file. And then that also allows us to be able to revalidate the local cache very easily, because for each piece of content in the system, we know the hash it's supposed to have. It's very easy using the kind of client's protocol up to the server for it to basically say, I have this for this file, and then the server can basically say that it hasn't been modified since the last time it was accessed or used. And we're still very pull-based in that sense, where the server doesn't push things down to the clients. The clients are periodically accessing the server and have various kind of algorithmic tricks that we've done, in the sense of, if you're asking for a specific path and the local client doesn't think it has it, then it will try and go up to the server and see if it can retrieve that. Which may even circumvent the kind of interval of cache freshening. And that's actually worked really well for us. We have hundreds of thousands of volumes across a few clusters. We have terabytes and terabytes of content. And it also works well for our backup agents too, because our backup agents can download the file system manifests as a kind of mapping of paths to hashes, and then they're able to populate the file system backup out of S3 rather than burdening any of our kind of real-time production infrastructure. And I've posted a bunch of blog posts on kind of the architecture and different evolutions of how we've done this system. Primary caveat in terms of, say, OpenShift in the community is this is all proprietary. And we're happy to talk about it a ton. We don't, at least currently, have any patents on any of the stuff, but we're not releasing the implementation because it's one of our differentiators versus our competitors right now.
Yeah, no, that totally makes sense, and I got that from the blog post that I was reading. But we do appreciate the insights, because I think the use of S3 and S3 buckets has been something that a number of the folks who have addressed this, the GetUp Cloud guys are using S3 buckets. They're doing a lot of special sauce things in order to make it work for their implementations of OpenShift. And there's a couple of blog posts as well on using S3 buckets with OpenShift. What you've done is highly optimized and shows off, I think, very well the years of experience you have working with Drupal and understanding the intricacies of it. I've been pushing for the SyncDiff approach for some time, and supporting John in his efforts, because we need. I don't think right at the moment we're supporting, beyond some of the Red Hat properties, any huge Drupal sites like you are at the moment. And the size of the gears and things right now contain the amount of images and the content for our clients. And when they don't, we push them over and get them to use S3 buckets and things like that. But it always feels to me like the SyncDiff and the conversations we have are a little bit of the SMB small site solutions. Unless you have a lot of money and huge gears, you can set gears to be whatever size you need them to. You're going to outgrow them at some point, and that's pretty clear to me. But also clear to me, I want something in the interim that works, and I don't even think, we're re-architecting a bit of OpenShift, quite a bit of OpenShift around Docker, and redoing the broker and other parts, but I don't think that's even going to give us the persistent file system solution. So I was hopeful there in that transition that something would come out of it. So I think we still need to pursue this thing differently, but I think as we grow in having to support more of the Drupal community and other folks with this persistent file system. I jokingly said, I think before we started, is that OpenShift's going to have to address this in some manner until the need for persistent files goes away and everybody stores everything in databases. But even then, like with some of the stuff you're describing about the images and the derivatives of images and generating that, there's a lot of stuff going on behind the scenes in Drupal. And so to make it really scale and efficient on a PaaS is quite a bit of work. That's totally recognizable.
And one thing I'd like to add, because a lot of people have kind of, when we embarked on this, considered us kind of crazy for embarking on writing a new distributed file system and to meet a lot of the needs that we have. But it's also important to remember the kind of engineering constraints, or the constraints of the problem set, where a lot of people try to design general purpose file systems for things like partial updates to files, locking, that really, or perfect read after write consistency. And a lot of these aren't really required for most applications like this. So when I say we have read after write consistency, we've bounded it to a few milliseconds. It's not perfect locked read after write consistency. You can't lock files on Valhalla at all. There's no real concept of partial updates to files, where if you update part of a file, then you're basically publishing a new file to the system that is, you may be able to write to do a partial update in the sense that you have a cached copy of the file locally and change part of it, but it's going to get pushed wholesale up to the system, rehashed, and then that's going to become the new version of it. And so we've optimized it around the kind of web media problem: CSS, JavaScript, image files, small audio files, smaller video files. The largest files we try to support on the system are in the maybe hundreds of megabytes. We really don't like to support multi-gigabyte files. Those are typically not the size of files that people are regularly working with in kind of real-time content management anyway. We try to work with customers that need the really large files to have some sort of integration where the application pushes those to something like S3, and then, excuse me, they can use something like signed URLs or direct links to those to make that more efficient. So I think we have a really sophisticated and optimal solution to a specific problem set, and that's what we went to do, and I think that's what we were able to achieve. And I think SyncDiff is actually focusing on a pretty similar set of use cases in terms of there's certainly not going to be locking in that kind of situation where things are getting kind of pulled between servers that way. And it seems like a very friendly solution to media files. The biggest blocker I see from a kind of Drupal persistence perspective is that kind of read after write issue, where it seems really hard to bound that down to a small enough window of time where another server is going to be able to read a file written to a certain path. So it might eventually be, and because it's kind of replicating it out to the local file system, it's very hard to trap the event of this file doesn't exist and therefore it can handle it in some way where it discovers it. I don't know whether that's possible. It might be interesting with SyncDiff to have some sort of thing where maybe there's eventually some sort of really tiny fuse wrapper that mostly just kind of directs to the local file system, but is able to trap the non-existence events and then be able to try and recover from that in terms of like maybe talking to the other nodes and seeing does any node have something at this path where if it hasn't gotten it yet, it's able to actually get it, copy it over locally, and then go right back to kind of being a pass-through. And I know that there are fuse implementations that are pass-throughs that basically just when you mount it somewhere, it just kind of does as much transparency to the underlying thing as possible.
Yeah, that's a possibility. I mean, it's not even to solve that read after write problem. That's not even a bad way to go. And you know, you're right. SyncDiff's not trying to, or it doesn't really, outside of your suggestion with the fuse, have a good way of trying to trap that problem. And you know, that wasn't a specific problem set that I was trying to solve. I was just trying to get the data across the nodes to begin with. So.
Yeah. That's my goal to start with. So for the beginning, SyncDiff's going to solve a lot of problems, but not all of the problems. There'll still be the missing files and gears and the disappearing images and all kinds of fun things too. So I think it's a great first step. The fuse wrapper sounds like an awesome, almost inspirational idea for it. So I'm really, that's a great piece of advice. And I think we all learn a lot from hearing from the experts too. And I hope we can take some of it back to the Google of Summer guys and see if we can coerce them into adding some of those thoughts into their approach to it. I'm probably going to send the URL for this recording to at least a couple thousand people, hoping to get them to take some eyeballs and some resource time to look at this, because it's a pretty persistent problem, as I keep saying, and I think we do need the community to collaborate across not just OpenShift, but other folks that are trying to solve this. The wonderful thing about OpenShift is that it is a polyglot ecosystem, so we're trying to solve lots of problems for lots of people, and though people is near and dear to my heart, it's not always the focus of everybody in the Red Hat engineering team, so I'm going to go out and reach out to some of my colleagues in the PHP and Drupal space, maybe even a few WordPress people, and see if I can't get some of them to work on this. And as I said, this has been really super helpful for me, and hopefully for the rest of the community. So I really want to thank you for your time today. And we've got a blog posted now on the Origin OpenShift.com blog site with some background on this. I'll post the URL to this there as well, and as well as through the SyncDiff.org, that's SYNCDIFF.org site. So if you'd like to join that mailing list, please do so. And hopefully there'll be something different on OpenShift shortly. And I really appreciate the time both of you have given me today. So thanks a lot, and I look forward to working with everybody. And all this great success of Pantheon, and thank you for the advice, David. Very happy to have you. Take care, everybody.